We can start now.
Okay, cool. So my name is Mohammed Imtiaz. I'm part of the BU customer enablement team, or also called the escalation and deployment team. So let me know if you can see the presentation mode fine, so we can get it started. All right. So let's get it started. As you can see, we have pretty full agenda. We'll talk about what is BGP flow spec, some of the protocol description, what is supported on certain platforms, how we have implemented that in the XR. Of course, we'll go through the configuration part, some of the very interesting use case scenarios, some tidbits where kind of quick help, you can call it, to the point, some of the bullet points actually. Then we'll talk about some of the features, other features versus a BGP flow spec, how if you configure that other particular feature versus the BGP flow spec, which come first in the processing and all. And then there are a lot of backup slides, and those backup slides are filled up with a lot of use case scenarios. So I have more than 100 slides, not planning to go over them. We'll go through first like 7 bullet points or so, and then we'll leave the backup slides on for you guys to go through. So we have pretty full agenda. Like I said, we may go over time, few minutes. I hope that will be okay in order to cover most of it, right? So let's get it started. So let's start with what is BGP flow spec is not. It is not NetFlow. It is not an open flow, and it's not a microflow policy, even though there are some similarities exist between most of these along with the BGP flow spec. But once we get into deep dive into the BGP flow spec, what it does, how it does, we'll see that how it is entirely different than the NetFlow, open flow, and some of the other features like you can also consider DDR as part of a comparison. But BGP flow spec is an entirely different feature. So before we go into the discussion of the BGP flow spec, let's try to understand the DDoS attacks and how to mitigate that, or what are the possibilities to mitigate that. So there are different natures of the DDoS attacks. One is the application layer attack, and one is the volumetric attack. So application layer attacks are the ones which are detected and handled by the firewalls at the end station or close to the end station, IDS, or at the server level. So these application layer attacks are, for example, the World Wide Web server or the FTP server and so on. No need to go into that detail. It's pretty self-explanatory with the name application layer attack. The second one, and probably the most common attack, the DDoS attack actually these days, is the volumetric attack. These are also called the flood attacks, and they also called the protocol attacks as well. These are the attacks which cannot be mitigated in the data center or at the server farm because it is too late at that point, because that attack is targeting the bandwidth, and it will consume all the available bandwidth, and will the end user will suffer that DDoS denial of service. So these attacks should be handled in the backbone or at the border router. And if you see that diagram actually from the internet, the peering transit, we have our AS autonomous system, for example, we have edge core and then the data center. So these volumetric attacks should be handled on the edge or on the core, ideally speaking on the edge, so it will not consume the bandwidth between the edge and the core as well. So BGP flow spec was initially designed with this thing in mind to mitigate the DDoS attack, and there are, like I said, a lot of use cases. We'll go into that. So in summary, BGP flow spec is a criteria or is a feature which mitigates the DDoS attack at the edge or at the core of the network. So what are the benefits of DDoS mitigation using the BGP flow spec? Right? One is a single point of control. That's one of the most beautiful thing about the BGP flow spec, and there are some more as well. We'll talk about that. But the single point of control where you control the whole network. Imagine you have hundreds of devices, and if you have to put the DDoS mitigation configuration on each router in our network, and we all know that our service provider network has a lot of entry points, a lot of peering points. So let's say even if they even have 10 of those peering points, you will have to configure at least 10 routers. So using the BGP flow spec, one center point, you configure those rules and just use the BGP in order to get that updates to those 10 entry points. Okay. One is the granularity, which means that BGP flow spec allows you a very precise description and the matching of the attack traffic. And we'll talk about that, what we can use to match that attacking traffic. And BGP flow spec can be used for both mitigation and the diversion. Mitigation means that you can just drop the packets, and diversion can be subdivided into two categories. One is to send it to the cleaning system, quote unquote cleaning system, where you clean the traffic and send it back. The other one is you just divert the traffic towards another link, or from a different network, you just send that traffic towards that network. And we have some of the examples about that too. And of course, you can offload the mitigation systems. So mitigation systems are those systems which actually clean up the traffic and all that. So using the BGP flow spec, you can offload those mitigation systems in order to process a more complicated kind of DDoS attack. So some of these benefits are coming from the BGP spec. So what actually BGP flow spec is? Well, it is a mechanism, a protocol to program the actions remotely. We already established the fact that we have a center point of, or one point where we send those rules to the peering point, right? And while we're talking about the BGP essentially is a routing protocol, means that you configure on both ends. So you have a center point, you have the peering point. So on the center point, you configure the BGP flow spec rules, and using the BGP session, it sends the update to the peering point, and those points install and program that in the hardware. So in a nutshell, this feature allows you to receive the V4 and V6 traffic flow specification, which could be based on the source address, destination address, or source network, destination network, any protocol, source code, destination code, and a lot of other criteria, and we'll talk about those criteria. So you can go into the inside the packet, take some of the features or the characteristics of the packet, like we mentioned, the source, destination port, and protocol type, and so on and so forth, and then identify that particular traffic and send the actions that need to be taken. Those actions could be drop, could be police, and could be redirect via, you use that, or you do that via the BGP update. So inside the BGP update, there are two things actually we need to understand. One is the matching criteria, which is represented by the BGP NLRI. And then the action criteria, which is represented by the BGP extended communities. And what are those extended communities will come in next few slides. So there are a couple of components in the BGP flow spec feature. One, in order to have that rule programmed remotely, you need to have a centralized controller. We call it the BGP flow spec controller, or we can also call it a server client model as well. So we need a traffic description, which is based on V4 and V6, and then we need an action. That traffic received on the client, on the ingress only. That's an important point here. The traffic which is acted upon via BGP flow spec rules is ingress only. So it matches the criteria, and then it will apply that particular action. Some of those traffic descriptions and the actions are shown here on the right side in the table, where your particular destination, when it matches to this destination, redirect in a dirty work dirty. You have UDP port 123, packet size 800 to 1500, you rate limit to 0 BPS. So this is important here. Instead of dropping, actually, there's no as such drop action, but rather you rate limit to 0 BPS, which is equal to drop in the packet. And then some of a couple of other examples. So in a nutshell, you have a controller where you define the rules using the BGP session, BGP flow spec session with the client. It sends the update, clients receive that update, and then install that update, program the hardware, and only applied on the ingress traffic on all the interfaces on the BGP client, BGP flow spec. So a controller actually programs remotely how packets should be treated. So if you look, it's essentially what we are doing. We are doing remote PBR, which means that we are redirecting packet in a particular word or towards a particular next hop IP address. So that's essentially the policy-based routing, right? So you match a criteria, and then you direct the traffic towards the next hop. It could be word, it could be IP. Then also you can remotely program the QoS as well, where based on a certain matching criteria, what you do is you do the DSCP remarking or do the DSCP marking. Then of course you can do the policing as well, and you can do the drop action, which is equivalent to having an ACL on an interface. And when we say policing, when we do the policing at 0 BPS, like we had talked about, that equivalent to have an ACL with a drop based on the matching factor. So if we look over here, we have a controller. We have a BGP FlowSpec session with these clients, BGP FlowSpec clients, and we send the update via the BGP update, just like the regular BGP updates being sent from the router sector to its clients or one router to the other. And then packet comes in, and then based on the matching criteria and the action, it is those actions are being performed: redirect, remark, or actually rate limit. So essentially, what we see is we have two components, controller and the client. We already established that. So on the controller side, actually, what controller does is it injects the rule remotely on the client or sends it to the client. Controller needs to implement the control plane at the minimum, means that it is not in the path of the data plane, and it don't have to be. It could be a server, it could be a router. So what it could be? It could be a NC 5500, AS 9K, CRS, and you name it. On the server side, you can have quite a few options. Mostly, I have seen the people or some of these customers, when they apply that, they use the Harbor, but of course, there are other options. And then you can, of course, use the XRV9K as a BGP. So if you have a simple setup of two routers, one router can be a controller and the other router can be a client. And this is a very easy feature to be tested. Very powerful feature, but a very, very easy feature to test and actually to configure and to maintain as well. On the client side, what we do is we receive those rules from the controller and program those match actions and those matching criteria and the action what need to be performed. And on the client side, we need to implement the control plane in order to receive those updates and the data plane in order to implement those actions. So example of those clients could, in our case, it would be a 5500 series router, SR9, multiple routers are supported. And we'll see what kind of support we have on each platform without going into a lot of detail of what exactly is not supporting on what line card and so on. But in general, terms actually what kind of router. Within the NCS 5500, some of the devices do not support the BGP FlowSpec. We'll talk about it. Let me know if I'm going a little too fast. I'm trying to cover the easy part of it, and then we'll, when it comes to the beefy part of the discussion, we'll try to slow down and feel free to ask any questions. Stop me anywhere, and we'll try to address that question if possible.
Mohammed, I was trying to find out the difference between why not just drop action and why 0 BPS. And I thought I'll Google and find out. I couldn't find out any. So would you be able to explain? Is there any value addition of rate limiting it to 0 BPS vis-a-vis dropping? I mean, the simple thing could be to just drop if you want to, right? So any reason why the standard goes with that?
Yeah, so it comes through the standard. I honestly do not have the nitty-gritty detail of why exactly it's not the drop. I tried to look up myself as well, and I'll continue to do that. Once if I find some information, I'll send it out.
Okay.
But as of now, I think it's coming from this thing. But yeah, it's a valid question, and I tried to look for that one as well in the past.
I went and Googled. See, I didn't want to interrupt the flow. It was going well, so I went and Googled.
No, that's a valid question, and actually, yeah, it is a valid question, and like I said, right, I tried that too, but we'll try to figure it out. And there are a couple of experts, probably either they are on the call or they will join the call, because there is a part of the discussion. Actually, I'll try to bring up at the end, where it's a very interesting discussion. It's not part of the agenda, so we'll see if those guys join, and they might be able to answer your question. Right?
So sure, go ahead. Thank you.
Let's wait.
So there is another
so
question, Mohammed.
There was another. Okay, Mohammed, go ahead. And there seems to be another question.
Yeah, it's coming up on the chat that can the controller be a cloud native one too?
Sorry, let me check the question here. Can the controller be a cloud native one too? Yeah, anything where you can establish a BGP session, right? And you can receive the update from the BGP. So it's as simple as that. You can establish a BGP session with a device in the cloud. Yes, we can these days. So that can be a BGP controller. Yes, it can. Does it answer the question? Sure.
Yeah, it answers.
So
Thank you.
let's move,
He just put a thanks there. Okay.
Thank you.
no, sure.
I have a question. I have a question
Sure.
regarding the controller. How the rule was injected in the controller? Is it manually injected or is
Okay.
manually injected
It's a good question again. So there are multiple ways. One is, and that's not part of today's discussion, but if I send the master deck of the slide, it actually discusses that part as well. So if you use those, let me go back actually. So if you use these servers, for example, and most of the service providers, they do not use router as a BGP prospect controller. It doesn't make much sense, to be honest, as well. For the testing purpose, yes, you probably don't have these softwares, these servers, but generally speaking, if you are using the router, you have to configure that command line or any tool you can use to configure that, right? But when you are using these servers, some of these are, especially when it comes to the Arbor, I have seen that very beautiful graphical user interface. And you have a lot of rules predefined actually, where you have to select those rules and then tweak some of the variables and so on and so forth. So to answer your question, generally speaking, these customers, they use the server actually using one of these software. And they don't have to configure it manually, but rather they can customize available rules. And then of course they can define their own rules as complicated as they can. We good with that?
Yes, thank you.
Okay, all right. So let's move on. So BGP FlowSpec component, route reflector, means that let's say you don't have route reflector. What will happen? You will have a BGP FlowSpec session from each client to the BGP FlowSpec controller. It's not scalable. Certainly, it's not scalable. When we have an infrastructure in the BGP, and we all know that BGP is deployed pretty much everywhere, and including the route reflector. So why have a session with each client rather just have a session with the route reflector? And route reflector will have its own BGP FlowSpec sessions with its client. It's already have, you just have to add the address family. We'll discuss that. But we use the route reflector infrastructure to send the rules to the route reflector, and route reflector distribute those rules to its client. Very important part of this is BGP FlowSpec is not bidirectional. It's a unidirectional in a way when we talk about the communication. Session, of course, BGP session is a bidirectional, but when it comes to the update being sent, only the BGP FlowSpec controller sends the update to the client. Nothing comes back as an update part from the client. So if we need to look at the data, we can use a CLI, we can use different tools, scripting, in order to either troubleshoot or to monitor what's happening on the client side, but nothing comes back towards the controller from the client. And also BGP FlowSpec abide all the rules BGP has it. For example, any BGP FlowSpec rule received from eBGP peer will be sent to the eBGP peer. Any rules received from the eBGP will be sent to the iBGP. And any rules received from the iBGP will be sent to the eBGP. But the simple rule with BGP has, when you receive an update from iBGP, will not be sent to another iBGP peer, right? Unless the router is a router reflector. So we know. So the point is the BGP FlowSpec abide all these rules, the basic rules of the BGP, and the way the BGP works, the BGP FlowSpec is just another address family. You can consider that along with a lot of other address families we already have in the BGP. So let's talk about, while we are on the address family part of it, let's talk about the what is that protocol exactly. So it is based on the RFC 5575. And why we are using BGP? First and foremost, it's simple to extend by using a new NLRI. couple of NLRIs were added. One is MP reach and one is MP unreach NLRI. And it's already used for a lot of other technologies, L2 VPN, L3 VPN, eVPN, and you name it, right? So the unicast and all. So once we already have that infrastructure in place, why not use that infrastructure? Just add few lines of configuration and voila, you have a very beautiful feature which can mitigate your DDoS, and it doesn't require new process to be started. Of course, it will add some memory usage on top of that, but that won't be drastic increase if you have another feature which will have its own memory space and so on and so forth. And then why we don't use the OpenFlow or the direct network, right? So first of all, like I mentioned, we have the strong framework already exists with the route reflector architecture. We have all this configured already in most of the network. And then we can actually cross the AS boundaries as well. These BGP flow spec, if we don't use the BGP, if you use, for example, let's say IGP, you will be confined within a boundary and so on. And IGP has its own limitations as well. So what are those traffic matching criteria? So let's talk about that. Some of them we talked about earlier. So destination IP address, source IP address, IP protocol port, destination port, source port, ICMP type, and so on. So order, keep in mind, order is important. We'll come back to that order part of it, but from 1 to 10, or it's this number, let's call it a type. So type 1 to type 12, we have different matching criteria, right? And then these are defined in the RFC 4760 as well as an MP reach and LRI. So matching criteria, important part of it is from type 1 to type 12. And then the same thing is shown in the packet. This is your DHCP, for example, right? Source port, destination port. You have ICMP type code and so on. So what we cannot match on, let's talk about that. We cannot match on the MPLS label number, on the MAC address, anything between L5, layer 5 to layer 7, they were like HTTP URL cookie and the DNS request, but rather our criteria are well defined as shown in the previous slide. And then what actions we can perform. So actions, most of them, we already talked about that: traffic rate, traffic action, redirect, and then traffic marking, right? So these are the actions. So traffic action is not supported. So traffic rate, we talked about that briefly. We can rate limit, and we can redirect, and we can do the DHCP remarking and so on. Traffic action is not supported as of now. So these are the extended communities based on the RFC 7674. Like for the example, redirect 2 bytes AS route target, redirect to IPv4 route target, and then you have 4 byte ASN route target redirect as well. So just a different type of the redirect, what we talked about earlier. And these are the extended communities. Remember that the matching criteria are defined by NLRI, and the actions are defined by the BGP extended community. And these are the actions we can have, or we can identify based on our matching criteria. And besides these RFCs, actually XR implements some of these additional IETF drafts. And we'll talk about at least one of them, if not all, just to understand that what it brings on the table and what are the benefits we can receive out of these additional drafts. But XR does implement these additional drafts as well. So coming to the part where what is supported on what platform. So these slides are pretty self-explanatory. This BGP flow spec is supported from which release on what platform. So I'll just skip through this part mostly. One important point here for the NSys 5500, like I mentioned earlier, not NSys, all the platforms support that. So what is needed is the Jericho Plus or SC-based platforms are the only ones which supports the BGP flow spec, because you need additional CCAM resources, and we'll talk about those CCAM resources as well. So for example, take these 5501 base version of it, it does not support the BGP flow spec. And that's where that topic I earlier mentioned, the off topic, can be very useful if we want to use the capabilities of BGP flow spec on 5501 or some of the platform which quote unquote do not program the BGP flow spec rules in the hardware. They can, of course, they can accept those rules, but they don't program them. So in those platforms, what we can do, if time permits, we'll talk about very briefly about that. So these are the different matching criteria, what is supported on what platform. Again, pretty self-explanatory, no need to go into that detail of that. If there are any questions later on, please feel free to do ask. In the previous sessions, when I had this presentation at a different towards different customer, I did receive a lot of questions about this, but feel free to ask any questions if you guys have. How XR implements that, right? So, like I mentioned, the BGP flow spec entries are stored in TCAM, and that's where the SE part or the Jericho Plus part comes in. What is the scale? That the question comes a lot from customer. It will come from you guys. So it is not an easy question to answer. The reason is this: you can have multiple matching criteria within the same rule. You can have multiple actions within the same rule. So it really depends on the rules. But in a nutshell, we have about 3,000 simple rules per line card. And that's important part per line card. I will address that in a second. Since we have the finite resources, and all these resources, what BGP flow spec uses being shared by the other protocols and other features as well, like TOS, ACL, and so on. So there is a limit. So let's talk about now 3,000 simple rules. So when we say simple rules, that's a broader definition. And to be honest, not going to go into that detail. It will take us a very long time. But per line card, we do not support BGP in such that you can download the BGP rules for certain set of interfaces, rule number one, and rule number two for certain other sets of interfaces. Let's take a line card with 20 interfaces, for example. So you want to have a certain rule for interface 1 to 10, and from 11 to 20, you have another set of rules. Not going to happen. That's not supported, right? So when we say per line card, it essentially comes per system, because all these rules are programmed on all the ingress line card, on all the ingress interfaces on all the line cards, unless you disable the rule on particular interface, which you will need in certain cases, and we'll see how and why we need that. But in order to understand the scale part of it, I will send out a document, actually, an XR doc document, which is coming from Nicholas Fabrier. He's a lead TME, actually, and he's the expert on that. I hope he is on the call, or he might join the call. But he has done a lot of testing, establishing the numbers that when we say the simple rule versus the complicated rule. So it's a very lengthy discussion. But in order to give the customer answers, the simple rules are those rules which do not have the port range, for example. You can have the multiple source addresses, multiple destination network addresses, but if you match on one particular port, then it's a simple rule. For example, that's one example, but there are, of course, other large ifs and buts in there. So we have a scale of 3,000 simple rules per system. That's what we support. So in the current implementation, as we mentioned, it is only applicable on the ingress, only on the physical or the logical interfaces, not on the tunnels, and only for V4 and V6 traffic. So this is some of the other limitations. We already mentioned that MPLS labels cannot match and on certain other traffic. So this is one of the examples which I just mentioned, that in certain cases, you will have to disable the rule on a certain interface. So let's talk about that, right? So packet coming in from the left to the right, and then you send a rule, and rule is match on a certain destination IP, which is matching 10.0 or 16.0. And then what is the action? Action, send it to the DDoS scrubber. And DDoS scrubber system is attached with this particular interface or on this network. Now, the problem is the BGP flow spec rule, once it's applied on the router, it's applied on all the ingress interfaces. Now your packet comes in, rule applied, redirect to the BGP DDoS scrubber. DDoS scrubber did what it's supposed to do, and then send the packet back to it. Now the problem is, if you send the packet back to it, the rule applied again, send it back, so it's a loop. That is one of the cases where you have to disable the BGP flow spec rule, knowing that what is connected on this interface or on this network in order to fully utilize the BGP flow spec capability. So let's talk about that, the configuration part of it. So on the configuration part, on both client and the controller, there are certain things we need to configure. On the client side and the controller side, we need to configure the BGP peer, which is the address and the flow stack for V4 and V6. And of course, you can have for VP and V4 and VP and V6. And then flow spec configuration on the CLI, and we'll talk about that. We have examples on that. Locally install interface all. This is where you install on all the interfaces, and then on certain interfaces, if you want to disable, you have to disable on those certain interfaces. On the controller side, you identify the traffic using the class map. Then you identify the action using the policy map, and then you have a flow spec service policy PBR command actually in order to apply that policy under the BGP flow spec. And once you have the session established, that policy will be advertised to the client. So this is the example here. Router BGP1, address family flow spec, neighbor, and then within the neighbor, you are of course using the neighbor group, and then address family IPv4 flow spec. Let's talk about the flow spec configuration. This is in the global config mode, flow spec, address family IPv4, and then the service policy, you have defined the name FS. So let's see what is that FS policy. We can define that FS policy using the policy map PBR command, and we have the matching criteria using the class map. And this is where on the client side, you do the flow spec local install and interface all, and of course, if you want to disable on certain interfaces, you can. So these are the matching criteria. You are matching the destination port. I'll kind of skip through this one because it's pretty self-explanatory as well. So you are matching the traffic, and then you are putting the action, just like any QoS, where you are matching the traffic, and then you are having the action being performed, and then apply on the interface. In our case, you don't apply on the interface, but rather this is how we apply on the controller side. So it's like address and IPv4, and then service policy type PBR, that's a keyword, and FS is here policy. So in this case, we are matching, and then we are rate limiting this particular traffic set, and then we are doing or performing the redirect to a certain next in this particular case. So here, what is shown here is you can have multiple rules actually, and all these rules will be applied on all the interfaces as we already established the fact. So what this is equivalent to this one, you don't have to, you can have the matching criteria or multiple matching criteria within the same policy map. Just like you can have multiple class maps within the same policy map for the QoS, same goes for the BGP as well. And different actions can be performed. You can perform the rate limit or mix and match actually. You can do the rate limit, and then you can do the redirect, you can do the rate limit and the DSTV marking, and so on and so forth. What is not possible to mix? You can redirect, you cannot redirect to WRF and the IP. Next hop, of course, these two are different things. And you cannot redirect to a next hop address 1 and next hop address 2. You cannot do that, right? It's only one next hop address. So this is just shown an example that if you are mixing the 7 matching statements, what happens. So this is the NLRI actually. We'll talk about briefly, but if you use this command, show flow spec AFI all detail, it gives you that this is a destination network, this is a protocol, destination protocol. So this is being programmed right here, DSCP 46 and so on and so forth, right? So source port, for example, let's take the source port 10, 20, 30, between 30 to 40, 50 to 52, and so on. So that's what is being defined, and then the packet length. So NLRI, taking this data, it converts that into NLRI. It's pretty complicated. Let's take a simple example here. For example, we are matching the destination address. And again, you don't have to know this thing, but just to understand how it is converted into the NLRI, right? So we are matching our destination address, IPv4, and this is the destination network. Now, this is type 1, if you remember. That's the type 1, type 2, until type 12, right? So destination address is type 1. So your type 1 prefix length is /24, convert into hexadecimal, your prefix convert into hexadecimal. And if you see 0, 1, 18, and then 51 FDC1, that's what comes down to your NLRI. Of course, this is a simple example. Previous one is very complicated, but if somebody wants to sit down and do the conversion, it will come down to this part. And you have to go with first type 1, type 2, type 3, and type 2. Of course, if a type is missed, then you can miss that part, but you cannot skip the type. It is configured in order to build the NLRI. This is another example based on the type 2. And so you have type 2, which is the source address, and it comes down to NLRI. And then within the hidden slides, you have all the example of type 3 until type 12. I'm not going to go through that one, but next, all 10 slides are example of type 3, type 4 until type 12. One very quick, actually, point. If you remember, we in XR we have implemented the additional draft. One was the BGP persistence. So what is that? From 5.2.2, we introduced the support of LLGR, long-lived graceful restart. So in a very quick definition, what happens? You have a controller, you have a client, you have a BGP session up and running, and then what happens? Your link goes down, your BGP session goes down. Now you already programmed some of the rules on the client. Now your session is gone. Now what happens? Having this long-lived graceful timer, actually, that timer will start. And currently it is 360 seconds, for example, you configure that, right? So it will count down till 0. And once it reaches to 0, it will remove the rule from the client, or it will just disable the rules, remove the rules, uninstall the rule, however you want to call it. But long-lived graceful restart is that feature. Actually, if you lose a session with the controller, what you do with the programmed rules which you receive from the controller. So until that timer expired, rules will be there, and that timer is configurable. So that's just one example of additional draft. As we can see, it is very useful feature, and of course the other additional drafts are as useful as this particular one. Okay, so this part is interesting and very important, but again, it's pretty straightforward as well. So let's see, we saw already the example of a matching criteria with the multiple types, right? So now what happens? Let's say you receive one particular rule from the client, then you received an additional rule, and then you received an additional rule, right? But all these rules are matching on a different criteria, different description, and different actions that to be performed, right? So now what happens in that particular case? Let's go in this example. You have this rule number 1, and then you have rule number 2. So you are matching on the destination address. You are matching on the destination address. This is the particular IP address, and this is the network, right? And then you are redirecting to two different networks, 3.9 and 4.9. And then you send those rules to the client, test 1 and test 2. Now, on the client side, you have these rules installed. Now what happens if a traffic comes with the destination IP 25.1.102.1, right? So in this particular case, it's pretty straightforward. The longest prefix will be matched. So it means that if the traffic comes in with 25.1.102.1, even though it falls into this category as well, this rule will win, and it will be redirected to the 4.93. As you can see, 4.9 is matching the packets and sending it out, and there's no match on this particular thing. Now, this is another very interesting scenario which I was mentioning earlier. You have 3 different rules coming from the controller, right? So suppose the controller sends us the type 2 rule, which is the source address, then type 3, which is the protocol, and then the type 11, which is the DHCP in different updates. So you have 3 updates matching on 3 different types. Now later, we send a traffic stream which is matching all these rules. That means that you have the source address which is matching rule number 1, you have the protocol type which is matching your rule number 2, and you have a DHCP value which is matching your rule number 3. Now you have 3 different rules. They are all installed on the client, and now one traffic stream hitting all those 3 rules. Now remember, you have 3 different actions configured on those 3 rules. Now you have one stream matching all those 3 criteria. Now what happens? Now the traffic will match the flow stack with the lowest numerical value, means that the lowest number will win. Let's say you did the redirection when you match on a certain source address, you drop on a certain protocol, and then you remark on the certain DHCP. So what will happen in this case? The type 2 rule will win, because this is how it works. The lower numeric value will win. So whatever action you are performing on type 2, or in our case, rule number 1, that will be performed. Let's take an example here. So you have source address 148401/32, and what is your action? Traffic rate at 7 Mbps. And then you have you are matching on protocol 255. Your traffic action is 5 Mbps, and then you are matching on DHCP 20, and your action is traffic rate is 2 Mbps. For example. Now you have 3 different criteria, matching criteria, 3 different actions. Now you send a traffic string with this particular source matching this, same protocol matching rule number 2, and then the same DHCP value matching rule number 3. Now what happens? According to our rule, actually lowest type number will win. Lowest type number in our case is the, in this case is the source network or source IP address. If there would be a destination IP address, that would have been, because that's type 1. But in our case, type 2, and as you can see, the traffic is being matched over here. No traffic is being matched. So you are actually rate limiting at 7 MB. So this is interesting actually to know. And a lot of time actually customers configure these kind of scenarios, and then they expect traffic to hit this rule or that rule, but it's actually hitting this rule. So the reason is lower type number will win if you have a contention between the actions among these multiple rules. Any questions here? How are we doing with the time? I'm sure
there are a couple of questions on the chat. Yeah, and
okay,
we have 15 minutes, 16 minutes.
Okay. All right, questions are on the chat, you said?
Yeah.
Okay, let's see. Does it support metering? Within the policing, actually, it does, but I may have to double check that one too. So that's from Anand Bharti. And previous question is, can a DP be connected to a multiple control plane? Data plane be connected to multiple control plane entities? Yeah, that's a good question actually from, I think, Paras. So let's, we have an example where you have, if I interpret that correctly, you have multiple controllers connected to one client. Is that right? Paras,
yeah.
If I'm
Yeah.
not mistaken?
Yeah, that is
okay.
right.
So we do have that example. We do have that case actually. Let's try to go there. But before that, these are some of the use cases, and I'm not going to go into detail. It's like essentially it's a PBR without configuring individually on the router. So you want a certain traffic to hit a certain link or certain next hop. Instead of configuring on the router manually, you can send it via the BGP flow stack. So certain matching criteria goes through this link. The other matching criteria or network goes through this link and that part. So you can essentially use BGP flow stack to do the same thing as PBR. Let's go to the slide where this actually answers your question. So in that case, let's see, we'll come back to, yeah, right here. So you have multiple controllers, and then they are sending the rules to the client. There is no communication between the controllers. So no controller to controller protocol is there to send the rules advertisement. So you are sending rule A, B, C, D by this controller 1, and then controller 2 is sending B and D. It will install all A, B, C, D. Now, what happens if this link goes down? You still have A, B, C, D rules coming from there, right? But in case actually, if this goes down, you will only have the rule B and D. So there is no communication between the controller. But if they are sending the contradictory actions being performed by the client based on the same matching criteria, then we already have the answer. It will perform the action based on the lower type number. But between the controllers, there's no communication. Those will be the individual controller. Client will take the rule because client is receiving the BGP update, actually the flow spec update from its neighbor. So there's no kind of route reflector kind of controller or the client configuration part on the controller side. So that's where you can have the multiple controller, but there is no syncing process in between between the controllers.
Hey, one more question there. So
right.
when the rules that you had, right? When the rules are conflicting, it'll just go with whatever comes latest and applies that, right? I mean, doesn't check where it comes from, etc.
No. Rules are conflicting. What that means? Can you describe that?
No. For instance, you had a rule B. You were talking about A, B, C, and D, and you said the other controller had say B and D, right? And if the rules are configured, the corresponding action are different. Though the rule is called A and B, I mean B and D on either, but the rules are conflicting. So the one that comes latest will just get applied, I'm assuming. Is that right?
No. There's no latest or the oldest one. It will program all of them. It will take the action based on the lowest stack number. It will program all of them from controller 1 and controller 2. So even though the matching criteria is same, but the action is different, so it's a different rule. Doesn't matter from where it's coming from, one controller or the second controller. So it will program all. And when the traffic is coming and matching the criteria from the rule from the controller 1 and controller 2, then it will see that which action needs to be performed. And that action needs to be performed by the lower type number. Now, based on your question, it seems like the type number is same. You are matching this on the same. You are matching on the same type number from controller 1 and controller 2. That will be interesting. In that case, actually, the second rule, which you write, the latest update coming from any controller will be programmed.
Okay, yeah, because the question actually, thanks, Mohammed. So basically the question I had was for the second thing. And basically what you're saying is it is going to look at the rule name and it's never going to see which controller it came from. Therefore, it doesn't differentiate. So it's not like controller comma A versus controller comma controller 1 comma A versus controller 1 comma A. So it is not going to be programmed as
rule name.
The same entry gets
replaced. The rule name is exactly same.
Yes.
Yep.
Yeah,
so
I was talking about that.
Exactly
the rule name is exactly the same.
So mine was also, I have a follow-up question on that. If like the rules are same, but actions are two different actions, then will it apply both the actions or just one action actually? Or the first action?
That's the question I also
asked. That will be one action, right? If you have the same rule, you have the same matching criteria, but the action is different. So one action will be programmed. Which action will be programmed? It's just like that, right? You are receiving an update from somebody, and then you are receiving the next update from somebody else about the same process. So you will install the second update, the latest update.
Okay.
Given that rest of everything is same, the rule name is same, the matching criteria is exactly same. Just the action is different. So you will perform the latest action being programmed.
Got it. That answers my question, Mohammed. Thanks.
Yep.
So the source is where it comes from is not is immaterial. It is just the criteria that matters. That was basically the intent of the question. Okay. Thanks.
Yeah. So we'll skip through some of these use cases. Like I said, they are pretty self-explanatory as well, and there's not very difficult part to understand that one over there. And then these are some of the tidbits. Let's see what we can learn from here. So most of these actually we already have identified. In this particular case, we are redirecting based on a certain matching criteria and how you can check that using the show command. So once you see the show command, you are seeing this is a rule actually, and then show prospect AFI all detail will give you the, let's say this is the control plane and this is your data plane or the what is programmed in the hardware. So this is programmed in the hardware. The destination 25.1.102.1/24 protocol, length of the packet, and then what is the action being performed. So some of the gotchas, and this is a little bit interesting, right? So what are the gotchas with the redirection action? A rule is advertised from controller only if the configured next hop is reachable through the controller. So take this as an example. This is your controller, show route 25.1.102.1. And now your rule is this, your neighbor, and this is your BGP flow set configuration. And this is when you don't have the next hop or the next hop programmed in the controller, you do not program on the client that particular rule. So that's one very important gotcha where, interestingly, the next hop should be reachable from the controller side, not from the client side, from the controller side. So you see the client is not programming anything. Once you configure the static route on the controller side in order to reach to 25.1.102.1, you run the same command again on the client side, you see the rule is programmed. So that this part is interesting. You would think that next hop should be reachable from the client side. No, it needs to be reachable from the controller side. But what happens if it is reachable from the controller but not from the client? Client will receive that route, but will just ignore it, will not program it. It means that there will be no black holing. You won't consider that, oh, it is installed and it will just black hole it because it cannot reach to the next hop. No, the rule will be programmed, but it will be just ignored or inaccessible. So there will be no black holing in that. And then there's a
So where is
consistency
this
checking,
restriction
that
coming from? Like we have to have the next hop reachable from the controller. Why is that restriction?
that's based on the standard. That's based on the standard.
Why I'm saying, like, if you have a cloud native type of controller, right, then it's possible that it is not reaching to the. This is the data path reachability, right? Actually.
Yeah, that's the interesting part, right? So it is a data path reachability, but next hop needs to be known by the controller, and that's where you can configure the static route.
Okay. I mean, but
So
that is like
in an example,
okay.
See, Paras,
Like,
I think I mean, I'm just taking a simple guess here, because if the route is known to the controller is supposed to be the all-seeing thing, right? So if it knows where that particular destination is, I mean, it doesn't have to be directly reachable. I think he's talking about the control plane being aware of the reachability of the next stop, of the destination or the next stop, not from the controller itself, if I understand right. Is that correct?
The route is route is
static route, we are trying to make it reachable, right? Just like that's what we are doing, right?
the route is distributed by the controller, I think, Shankar.
Yeah. So
Otherwise, no, there can be DDoS attack, right? Somebody else can program and redirect the traffic and all, and from unknown source.
I see.
Right?
I see.
Yeah.
No, okay, so in that particular case, not necessarily a route is being advertised by the controller. So because you just have the BGP flow spec session with the controller, you don't have IPv4 unless you do have the IPv4 session as well. But in general case, actually, you just have the BGP flow spec address family configured. So you are not receiving the routing information from the controller, the flow spec. Okay, so this is pretty interesting as well. We do have the consistency check. It means that if you match on a protocol and then you match on the ICMP type, these two are not go together, right? So you're within one matching class map. So you have to, when you are matching the TCP protocol, you should match on a TCP port, for example, right? Same goes for you are matching the ICMP protocol and then you are matching the TCP flag, doesn't go hand in hand, and it will show that match is unsupported and so on. So we do have the consistency checking as well. We went through this particular scenario. Okay, so this is another interesting discussion where we have multiple features configured and how that works out along with the BGP flow spec. So we took the example of QoS, NetPro, ACL, and ABS. So if the QoS is configured already on an interface and a BGP flow spec rule comes in, then what happens? And same goes for ACL and ABS as well. So the local QoS configuration will come before the BGP flow spec processing. So what it means is local configuration will police and the DSCP mark if configured. It will do the DSCP marking on the packet and then pass it to the flow spec. And then the flow spec will do its processing, whatever it has to do, policing or redirection, except the DSCP marking. So let's say you have a QoS policy shaping or policing at, let's say policing at 100 Mbps. And then you did a the redirection as well. And you are setting a DSCP value in a QoS policy. Now, a BGP flow spec rule comes in, matching on the same criteria, and instead of policing at 100 comparatively to QoS configuration, you are policing at 50 Mbps. And then you are redirecting to a different next hop than what you have configured in QoS, for example. and you are doing the remarking in the BGP prospect as well. It will do the redirection, it will do the policing as per the BGP prospect rule, but it will not remark the DSCP. It will keep the DSCP value from the local queue authentication. So that's where, to some part, the BGP prospect rule will win when it comes to the redirection and policing, but when it comes to the DSCP remarking, the local QoS policy will win over the BGP prospect. This is the example, same thing mentioned, what I mentioned, 15 Mbps and next hop, but it will not override the DSCP marking traffic. Will be forwarded with the AF11 instead of AF43, which is AF43 is being programmed by the BGP flow. When it comes to the net flow, BGP flow spec rule drop the packet. Even if it drops the packet, they are still being sampled and handled by the line card CPU. So compared to the net flow, if you are dropping the packet, it will still be sampled by the net flow. So this is the example where it is you have a drop ACL deny. For example, you have configured the ACL via BGP prospect, and it is dropping, but it is still being sampled by the BGP by the net. When it comes to the ACL, it's pretty straightforward that ACL will be applied before the BGP prospect configuration. So in an ACL, if you are doing you are denying certain UDP traffic, and you are doing the same matching criteria in the BGP prospect. Let's take the example here. What we are doing is 25.1.102.1. That's a destination protocol pair, packet length pair. So here you are redirecting, and over here you are denying means you are dropping. So you see there is no packets being matched to the BGP prospect rule, but rather all the packets being matched on the ACL side. So ACL wins when it comes to the ACL versus the BGP. Last but not least, ACL base forwarding or PBR versus the BGP prospect. So if you have configured the ACL base forwarding and a BGP prospect rule comes in, asking it to send it to a different next hop, in that case, the BGP prospect rule will win and will send it to the next hop, which is configured via BGP prospect. So PBR versus BGP prospect will win in that. So some of the quick caveats. So hardware module profile prospect v6 enable command and v4, of course, it will degrade the performance as we expect, right? So because it needs further processing of the packet. We already know that the prospect processing is only on the ingress side and during the L3 lookup, and we don't do any processing of prospect processing on the MPLS packet. BGP prospect will not process packet when it's received on the GRE tunnel. We mentioned that it's not supported on the BVI interface, it's not supported on the multicast, and it does not police at L2, not on L. Actually, it does on L2, not on L1. So L1 header is not being counted. So some of these quick steps. And these are just the conclusion part of it, of the discussion. What we went through, all of it is just summarized it. Last but not least, this is a video actually. This is, I believe it is from Nicholas Fevrier, as I mentioned earlier. He did a lot of work on the BGP prospect. He wrote quite a few documents on XR doc as well as on the internal sites as well. But going through this video training, actually pretty much what I have covered is being talked about in this training in probably more detail. And there will be some other links I will be sending out in order to have more detail if you guys would like to go into that detail. And then I have a lot of these use cases in the backup slide. Definitely, you guys, if are interested, would like to go through. They are pretty straightforward and simple scenarios, but they are very useful scenarios in the production. So I think there's a question about the link of Joy of Learning portal. It is in the invite itself. So if you see the invite has the links and the recall all the previous sessions information. So we are able to actually get through on time pretty much. Just give me a couple of more minutes. A very important thing I would like to just bring it up. It's not in the agenda because it just came to me pretty late. And if Mikhail is on the call and if Nicholas is on the call, please help me out. But what happens, let me share this part as well. So as you guys can see that this is the document. So what happened in a case where the product or the platform or the line card do not support the BGP flow spec? And as we saw that, it's a pretty beautiful feature. You use a centralized controller to send the rule effortlessly, right, pretty much. So what happened if there's a 5501? So without going into detail, and this will be probably a session based on the interest, and Akhilesh, someone will reach out to you and see if there is an interest for this particular session. But in summary, what these guys have done, very good work. What they have done is there is a BGP flow spec to ACL script. So what it does is, in those platforms, in those line cards where it's not supported, it takes the BGP flow spec rule and converts into ACL and programs it. So that script keeps checking the BGP flow spec update every few minutes or few seconds, depending upon the, I think, the script configuration. But it takes those rules and converts that into ACL and programs those ACL on the ingress side of the interface. So like I said, without going into the detail of it, and as you guys can see that it's a lot of detail, these guys have done a lot of testing as well with a lot of examples. But in summary, you can receive the BGP flow spec rule using this script. It converts those rules into an ACL and programs those ACL on the ingress side of the interfaces. Now, what happens if you already have an ACL already there? And what happens if you don't have ACL? So these are different cases. Actually, if you already have the ACL, it will just append or add that information within the ACL. If you do not have an ACL, it actually, what this script does, it when you run this script, actually initially it will have an ACL configured on all the incoming interfaces, ingress interfaces with a permit any. Initially, and then when it receives the update, the BGP flow spec update, it will accordingly convert that into the ACL statements and program that ACL on those interfaces. So, like I said, it's a pretty good work. And if you guys are interested, actually, those guys would be more than welcome, more than happy to come over on this platform and describe that, and probably will run through some of the steps if needed. So Akhilesh, like I said, somebody probably will reach out to you for this session if there is a proper interest from the audience. But I tell you that it's a lot of work, and it's a lot of very good work done by Nicholas and Mikhail and some of the other guys Mike mentioned here.
We will certainly schedule this session. Thank you so much.
All right.
Wonderful session.
Yep. Thank you, guys. Thank you. I know we just ran over a little bit time, but like you guys saw that it was a lot of content. Some of them I rushed through. They were straightforward. And there are a couple of questions I need to get back. I'll try to get those answered and we'll send it out to Akhilesh and he can distribute them. Thanks a lot.
Yeah, thank you, Mohammed. It was a good session.
Session recording and slides will be available on Joy of Learning portal by tomorrow end of the day. Thank you so much for attending. Thank you.
Thank you, guys.